So, assignment number 12. Prop. I know you see that. Got it.
Oh, and
Yay!
again, and again. It's having hard time.
I got it.
There you go. There you go.
Boom. Problem one. So, we have a third degree polynomial of 2x cubed plus 3x squared minus 7x plus a 6. And the freebie after the semicolon is -3. So you should have done a bunch of these while I was gone. Um, a lot. So we're going to synthetically substitute -3 with the full understanding that we should get a 0. So we're going to take these numbers in front, the 2, the 3, the -7, and the 6, and we're going to synthetic substitute the 0 that's given. In this case, it's -3. And like I said, if you know you have a freebie, then you should be within your rights to put a 0 there, sort of expectantly. And then we're going to work it down, and we're interested in the numbers that will appear in this green cloud thing. That's the target, right? The 0 we kind of assume will happen. Those three numbers in the box or the bubble, the cloud, that's what's interesting. So we're going to drop the 2, and we start -6, add -3, multiply, add 2, multiply -6. So the difference between this and assignment 10 is what? It can't necessarily be factored. I do think there's one of these six. I don't remember. I made this last night. I think I made one of the six be factorable, and I'll let you figure out which one that is. Um, so if you test for factoring every time, which is fine, then every time you're going to, take these out, and you're welcome to sit and do this. I leave that up to you completely. Uh, if it's factorable, then there should be some combination of this that will work. And you will quickly figure out that they both have to be minuses. This isn't going to work. If you put a 2 here and a 1 here, you get -4, -1, -5. And if you switch those and put your 2 here and your 1 here, you get -2, -2, -4. It cannot be factored. So what separates this assignment from number 10 is that now you possess the requisite skill to finish. The quadratic formula will be required. So we're trying to solve that white quadratic equation at the bottom of the screen. Factoring proved to not work. Therefore, we bust out the big guns. The big gun, in this case, the quadratic formula. So my A value is 2. My B value is -3. And my C value is 2. And we pop it into the old quadratic formula. So I'm just doing one of these together with you, and then I'll get out of your way. Just want to make sure you're clear on what's happening. Why are we doing another one of these? It's not the same. So x will equal what? 3 plus or minus a big long square root sign. And what goes first in there? 9. B squared -3 squared times itself, whatever, is 9 minus 4, and then put two little hungry baby birds kind of waiting to be fed, all divided by 2 times a, which is 4. And then in the little spaces, we're going to put a and c. B's work is done. So we're going to put in a 2 and a 2. And then we work. Is this going to be an instance where this minus stays or switches? It'll stay. Yeah, the only time he'll switch is if there's a negative later on down the line to cause him to switch. And so at this point, you just do some math. So it'll be imaginary. Good job, Landon. We know that because the answer to this yellow box, even if you don't know what it is right away, you should know right away it's definitely bigger than 9, right? So 9 minus more than 9 equals negative. So what is the answer to the yellow box? 16. 4 times 2 is 8. Answer times 2 is 16. What is 9 minus 16? Right. So the answer in its current state is 3 plus or minus the square root of negative 7 over 4. And that answer is pretty close to done. What's the one modification we need to make? Got to mess with the root. And that means a lot of different things depending on the situation. Sometimes you have to pull it out and make a little tree and reduce it again. And this is not one of those times. 7 is clearly a dead number, right? You don't have to have a math degree to know that. But what's the change we have to make? Yes, you got to get the I out of there, right? We don't leave roots with negatives. So we're going to take this root out. We're going to fix him up and say, I don't think that's your real name. Your real name is I with a leftover root of 7 because he's imaginary. And then we're going to pop that new and improved version back in. The Dorito will never have any, like, you can't make progress if the root is not workable at all. Like, and that was just a dead root from the get-go. The lack of a number right where this green arrow is pointing, like right there, exactly there, that would be the only way there could be a number that would enable this division thing to take place. So the final answer to the problem is not on the board yet. What is the final answer? Here, I'll erase all of this. The answer is still not on the board. What is the answer? Don't forget that you also have to state that x equals -3. The one that you're given for free, you don't want to like forget about it. You used it a long time ago. I get that, but it's still one of your 3 answers. And remember that there are 3 answers in that box. 3 plus I root 7 over 4 and 3 minus I root 7 over 4 and -3. So that's really all I have to say today. I'll keep the recording going. Just pause. If you have any other questions on assignment 11, which is just quadratic formula, or assignment 12, which is this, let me know. Sound good? All right. Happy working. Let there be work time.